And this lecture we will study about some special notations and special matrices which will be studied for the first time in your course. You didn't study these kinds of matrices and notations in your previous classes, so be attentive and be ready to get out of that hurdle. In order to start, we need to know about a notation, and that notation is, for example, if we are given a matrix A, say, and these are the entries of that matrix A11, A12, A13, and so on. So this A11, it means that is the entry or element of this A matrix, which is in the first row and first column. You see, this A11 is in the first row and first column, so that's why this entry is denoted by A11. Similarly, if you look at this entry A12, this entry is in the first row and second column, A12. So that is the first row and that is the second column. So A12 is the entry of this matrix A, which is in the first row and second column. The first number represents the row number and the second one represents the column number. Similarly here A13, so A13, that is the entry which is in the first row and third column, so that is the first row and third column. And if you look at this A23, so that is the entry which is in the second row and third column. So you see, this A23 is in the second row and third column. Just look at this A32. A32 is the entry which is in the third row and second column. So that is the third row and second column. So this notation Aij is the entry of the matrix. I stands from row number, for row number, and J stands for column number. Aij, A13. So I is 1 in this case and J is 3 in this case. Similarly A33, so I is 3 and J is 3. So Aij is the entry of the matrix. This Aij is denoted by another notation which is Aij, capital A, I, comma J. This A stands for this matrix A. For example, if we denote this matrix by B, then that A will be replaced by B. If you denote this matrix by C, so we will replace this A by C. Anyways, so that is the matrix actually. The matrix whose entry in the ith row and jth column is actually Aij. For example, A11 in this case, A11 will be denoted by A11. I mean, that is the entry of A matrix which is in the first row and first column. Similarly, A12 will be denoted by A1, comma 2. It means that the entry of A matrix which is in the first row and second column. And similarly A32 will be denoted by A3, comma 2, and so on. So that is the notation which will be used here in your course. Secondly, identity matrix. Identity matrix, that is a simple matrix, and you have studied this matrix in your previous classes. So first of all, identity matrix is actually a square matrix. Square matrix is that matrix in which the number of rows and columns are same. So a square matrix is called identity matrix if the entries of that matrix, all those entries 1, so one entry will be there for which I equals to j. Aij is equal to 1 whenever I is equal to j. I is equal to j means this I and this j are same. So just look at this. A11 ij are same. A22 ij are same. A33 ij are same. So that is the main diagonal of this matrix. So whenever there is I equals to j, it means that this is the entry of main diagonal. So whenever the main diagonal of a matrix, a square matrix, is 1 and the rest of the elements are 0, I is not equal to j. So whenever I is not equal to j, all those entries will be equal to 0. Just look at this entry. I and j are not same. Here I is 1 and j is 2. So this entry will be 0. Similarly, this entry will be 0. 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 This diagonal I equals to j, this entry will be equal to 1. Similarly, this entry will be equal to 1 and the third one, A33, will be equal to 1. So that is the identity matrix. For example, if I equals to 1001, that is a 2 by 2 identity matrix, and that is 3 by 3 identity matrix. This third note is very important regarding your coming questions and coming all topics, that elimination or elementary matrix. What is elimination matrix or what is elementary matrix? Because of this E, elementary matrix or elimination matrix is denoted by E, and suffix there is ij, just like this ij. Eij, elimination matrix, subtracts a multiple L of row I from row j. Subtracts, this E will subtract a multiple L of row j, the second number, row j, from row I, the first suffix, has an extra minus L entry in the ij position, and the ij position, minus L entry in the ijth position, in the ith row and jth position. We will explain this Eij in the coming portion, in the coming slide. You just need to remember this definition of Eij, that Eij, that is an elimination matrix which subtracts a multiple L of row j from row I, and which has an extra minus L entry in the ijth position. The fourth one is permutation matrix. So what is a permutation matrix? Permutation matrix will actually will be denoted by P, because of this P, Pij. So permutation matrix is that matrix which exchanges row I with row j. So whenever you exchange two rows, so that matrix is called permutation matrix. And the fifth one is pivot element. The first non-zero element of a row is called its pivot. The first non-zero element of the row is called its pivot. For example, if you look at this identity matrix, that is the first row, and the first non-zero element of this row is 1. So the pivot of this row 1 is 1. Similarly, row 2 and row 2, the first non-zero element is 1. So the pivot of this row is 1. And the pivot of row 3 is 1. So the first non-zero element of a row is called its pivot. For example, if you look at this matrix A, then we see that the first non-zero element of first row is 1. So pivot of row 1 is 1. Similarly, the second row, and this second row, the first non-zero element is 2. So pivot of row 2 is 2. And similarly, the pivot of row 3 is -1, the first non-zero element. So that is the pivots of those rows. Here is an example. In this example, we need to find elimination matrix E21 by subtracting 2 times row 1 from row 2. Subtracting 2 times row 1, just look at this, 2 times row 1 is subtracted from row 2. So R2 minus 2 R1. And secondly, and E23, we need to find E23 by subtracting 5 times row 2 from row 3. Just look at this thing. 5 times row 2 is subtracted from row 3. And the third one is we need to find E31. So E31 by subtracting row 1 from row 3. Row 1 from row 3. And that is row subtracting 5 times row 2 from row 3. And subtracting 2 times row 1 from row 2. So all those things, that is subtracting 5 times row 2 from row 3. Just look at this E21. If you look at E21, so E21 should be obtained by subtracting 2 times row 1 from row 2. 2 times row 1 is subtracted from row 2. So that is denoted by E21. Just look at this order 2 1. So that is 2 times row 1. 2 times row 1 from row 2. E32 is subtracting 5 times row 2 from row 3. 5 times row 2 from row 3. Similarly, row 1, subtracting row 1 from row 3. Row 1 from row 3. So remember this order: row 1 from row 3, row 2 from row 3, row 1 from row 2. This is the order actually. Now how many times that will be given to you, or you may know it by from the given matrix, that how many times a row should be subtracted from this other row. Anyways, we need to find these elimination matrices, and secondly we need to find these permutation matrices P13, P32, P12. P13 means we need to permute row 1 and row 3. I mean, we need to exchange row 1 with row 3, exchanging row 3 with row 2, and exchanging row 1 with row 2. So for this purpose, Thirdly, we need to find the product of all these elimination matrices and the product of all these three permutation matrices. So let us start. We need to find these elimination matrices in the sense of identity matrix. What does it mean? It means that we'll take an identity matrix and do these operations right over here. So in order to find E21, by subtracting 2 times row 1 from row 2, 2 times row 1 from row 2. So E21 is 2 times row 1 is subtracted from row 2. So here we need to write row 2 first. So writing row 2 first, which is 0 1 0 0 1 0, and multiply row 1 with 2. So multiply row 1 with 2, so that will become 2 0 0. E21 will be obtained by subtracting 2 times row 1 from row 2. So in order to perform this operation, we have written R2 minus 2 R1 and the side work R2 minus 2 R1. First of all, we need to write R2 here. So R2, second row of this identity matrix 0 1 0, and then multiply 2 with R1. So multiplying 2 with this row 1, 2 ones are 2 0 0, so that is 2 0 and 0, and then subtracting these two. So whenever we subtract two numbers, so changing the sign of those numbers, plus 2 will become minus, that will become minus, and that will become minus. 0 minus 2 is minus 2, 1 minus 0 is 1, 0 minus 0 is 0. So minus 2 1 0, this obtained answer will be written in R2. So we have written minus 2 1 0 and R2. So that is the operation R2 minus 2 R1. This is E21. If you look at this E21, we have subtracted 2 times row 1 from row 2. So 2 times row 1, just look at this thing, minus 2 is here. So whenever you are subtracting 2 times row 1 from row 2, changes will occur in row 2. So row 2 has been changed, and the main change is that this 0 is replaced by minus 2. So which number is multiplied by row 1, the negative of that number is introduced and row number 2. So E21, whenever you subtracting 3 times row 1 from row 2, so minus 3 will appear here. Whenever you subtract 5 times row 1 from row 2, so minus 5 will appear here. Whenever you add 5 times row 1 with row 2, so plus 5 will appear in row 2, and so on and so on. So that is E21. Similarly, if you want to find E32, we need to obtain E32 by subtracting 5 times row 2 from row 3. So we are subtracting 5 times row 2 from row 3. So it means that changes will occur in row 3, and that changes there will appear minus 5 and that place where 1 is there in row 2. So 1 is there in row 2, so below there in row 3 minus 5 will appear. If you perform this operation on side work, R3 minus 5 R2, so write R3 first, R3 of this identity matrix 1 0 0, and multiplied 5 with R2. So we have written R3 first, 0 0 1, the identity matrix, and then multiplying R2 by 5. So multiplying R2 by 5, So that will become 0, 5, 0, 0, 5, 0, and then we need to subtract, so change this positive sign, that will become minus. 0 minus 0 is 0, 0 minus 5 is minus 5, 1 minus 0 is 1. Now this obtained answer will be written in R3. So we have written that obtained answer 0 minus 5, 1 in R3. What is the main change? The main change occurs in row 3, this row 3. Here the main change occurs in row 2, this row 2, and that changes that number which we are going to subtract from subtracting 2 times row 1 from row 2. Minus 2 is appeared in R2. So you see minus 2 is appeared where there is 1 above R1, and minus 5 will appear in R3. Minus 5 will appear in R3 where there is 1 above R2. So that is E32. Similarly, E31, we need to subtract row 1 from row 3. So row 1 is subtracted from row 3. We know that there is 1 with row 1. So minus 1 will appear in row 3 where there is 1 in row 1. So you see 1 is here in row 1. So below this 1, minus 1 will appear in row 3. And here minus 5 will appear in row 3 where there is 1 in row 2. So you see in row 2 1 is there, so below this 1 minus 5 will appear in row 3. Similarly, minus 2 will appear in row 2 where there is 1 in row 1. So you see in row 1 is here, so below here in row 2 minus 2 will appear, and the rest of the matrix is unchanged. So that's how we calculate these elimination matrices. Remember that thing. Now we need to find these permutation matrices P13, P32 and P12. So P13 means interchanging row 3 with row 1. This is the symbol for interchanging row 3 with row 1. So interchanging row 3 and row 1, these two, so we'll get P13. And P32 will be obtained by interchanging row 2 with row 3. So interchanging row 2 with row 3 in this identity matrix, row 3 and row 2 will be interchanged to get this P32 matrix. And the last one is P12. It means that we need to interchange row 2 with row 1. So interchanging row 2 with row 1, interchanging row 2 with row 1. So that is the interchanging of these two rows. So we have here P12. So that's how we get these permutation matrices and these elimination matrices. You need to concentrate and focus these elimination matrices, and that is a very simple way to obtain elimination matrices. Now in part number 3, we need to find this product, the product of these elimination matrices and the product of these all permutation matrices. So in this coming slide, we need to calculate the product of these elimination matrices and these permutation matrices. So first of all, we have taken this product. This is E21, which we have obtained in the previous slide. E32 is this one, and E31 is this one. Now how to multiply two matrices? We have discussed this in the previous lectures. However, we need to multiply the row of first matrix with the column of second matrix. You can multiply these two first and then multiply with this E31, or you can multiply these two first and then multiply the obtained answer with this e21. Anyways, first of all we need to multiply this matrix with that matrix. So whenever you multiply this matrix with that one, 1 into 1 is 1, then plus sign is there, 0 into 0 is 0, then plus sign is there, 0 into minus 1 is 0. So that is the product of first row with first column. Now first row second column, 1 into 0 is 0, 0 into 1 is 0, that is mistakenly written here, that must be 0. So here we are, that will become 0, 0 into 0 is 0. Now multiply this first row with the third column, 1 into 0 is 0, 0 into 0 is 0, 0 into 1 is 0. So this is the product of first row with all these three columns, and now close this square bracket. Now multiply the second row with the first column, 0 into 1 is 0, 1 into 0 is 0, and 0 into minus 1 is 0. Now multiplying the second row with the second column, 0 into 0 is 0, 1 into 1 is 1, 0 into 0 is 0. And lastly, multiplying this second row with the third column, 0 into 0 is 0, 1 into 0 is 0, and 0 into 1 is 0. Now multiplying this third row with first column to obtain this answer, and now multiplying this third row with the second column to obtain this portion, and multiplying this third row with the third column to obtain this portion. Now 1 plus 0 is 1, that will become 0, and that is 0, and similarly all those sums have been calculated. Now we are in position to multiply these two matrices in the same manner. This first row will be multiplied with first column. So first row first column, 1 into 1 is 1, 0 into 0 is 0, 0 into minus 1 is 0. Now the same first row with the second column, 1 into 0 is 0, 0 into 1 is 0, 0 into minus 5 is 0. Now multiplying this first row with the third column, 1 into 0 is 0, 0 into 0 is 0, and 0 into 1 is 0. So that is the product of first row with all these three columns, and now closing the square brackets. Now in the same manner, multiply this second row with the first column to get this sum, multiply this second row with the second column to obtain this portion, and multiply this second row with the third column to obtain this portion. And now lastly, multiply this third row with the first column to obtain this portion, and multiply this third row with the second column to obtain this portion, and multiply the third row with the third column to obtain this portion, and calculating that sum to get this answer. So the product of all these three elimination matrices is a matrix, this one, and we see that this matrix is lower triangular matrix. Lower triangular matrix is that matrix in which above main diagonal all the elements are 0, and below main diagonal not all the elements of this triangle is 0. There may be only one number which is not 0, maybe two numbers are 0, but one of these three numbers must not be equal to 0. Anyways, this is the product of these elimination matrices, and now we are going to calculate the product of these permutation matrices. So P13 multiplied by P32 and all these. In the same manner, multiply this P32 with P12, multiplying first row first column, first row second column, first row third column, and now second row first column, second row second column, second row third column, and now third row first column, third row second column, third row third column to obtain this matrix. Now multiply this with that matrix to get this matrix, and now calculating this sum to get this answer. So that is the product of these permutation matrices. So this is all about the product of elimination matrices and permutation matrices. And in elimination matrices we have learned some new things, that how could we obtain elimination matrices directly.